This is example number 6 in the list of worked examples highlighting how to apply the precedence formula, that is F-DWAP. This example is simple enough, as we see shortly. It says 3 bracket x minus 5 plus x is equal to 3x minus 5. This is the given equation for us to solve. If you watch this equation carefully, you will see that there is going to be a need for unification, but no need for making the divisor 1. Most of the time, after unifying, we'll discover that we have removed the adder, made it become 0. Similarly, we have coefficient of x, which is 3 here, but later we might discover that its coefficient, after we collect like terms, might be 1. In any case, we just state loosely that we have 2 scales, though in actual sense there is going to be just 1 scale in solving this equation. Those 2 scales are unification and making coefficient become 1. The strong one and the major one being unification. All right, in solving this equation, we sense that the x, which we are solving for, appears more than once in the entire equation. It appears here, it appears here, it appears here. 3 different places. All those 3 appearances must be made to the 1 appearance. How do we do it? We do it by collecting like terms. Is there any obstacle to collecting like terms here? Yes, there is. This bracket is an obstacle to collecting like terms, so we have to open it. I therefore use this 3 to open the bracket. 3 times x is this 3x. 3 times minus 5 is minus 15. Then 3x minus 15 is therefore the result of this bracket after being opened. Then this x is the same x here. Then 3x minus 6 is still here and equal to separate both sides of the equation. This way, we say that the bracket has been opened. Just 1 bracket opened. Is it now time for us to collect like terms? Surely there is no more any other obstacle. There is no more any other obstacle, and we can proceed to collecting like terms. Minus 15 and minus 6 are like terms, while 3x, 1x, and 3x are like terms. Without going back to all the details involved in collecting like terms, let us practice it the simple way. The simple way that is a summary of those details. By now, we must have known the details of collecting like terms. The summary of those details is what we're going to apply here. What is it? When collecting like terms, if any number has a need to cross equality sign, let it change its sign. Then if in the course of collecting like terms, a number does not cross equality sign, let its sign remain. If this x is being taken to stay with 3x, will the sign change? No. Why? It is not crossing this equality sign. Therefore, this x remains this x here. Will this 3x, which is plus, become plus 3x when it comes to left-hand side, or minus 3x? Certainly, because it will cross this, it is going to become minus 3x. Don't forget that what I'm doing right now is summary of the details, summary of the principles we learned while learning about how to collect like terms. The summary is what I am applying here. That summary is what empowers me to say what I'm saying. That is that whenever a number crosses sign of equality in collecting like terms, that its sign, if it is plus, we turn to minus, and if minus, we turn to plus. But if a number collects to another like term and it does not cross the equality sign, its sign will not change. So 3x and 1x are together. The signs are maintained. Why? They didn't cross. But this plus 3x has become minus 3x here. Why? It crossed. This minus 15 will also come to join minus 6. In doing so, it crosses this sign of equality. Because of that, this minus 15 becomes plus 15, giving rise to what we have here. 3x plus x minus 3x is equal to minus 6 plus 15. In this case, like terms have been collected. Okay, now simplify both sides. That will be 3x plus x is 4x. 4x minus 3x is 1x. So 1x is the result of all of these things. It is because at last, what we have here as its coefficient is 1. That I said at the outset that there may not be a need to change coefficients to 1 because by coincidence, 1 has become its coefficient just after this unification. It is never compulsory that after unification that the unknown will have 1 as a coefficient. This one is just a coincidence. So that is why I did not remove that C as one of the skills we should apply in solving this equation. By coincidence, after collecting like terms in x, x has come to have 1 as its coefficient. We take it that way. Then minus 6 plus 15. I'm owing 6. I have 15. After counting, I'll have 9. Therefore, left-hand side gives us 1x. Right-hand side gives us plus 9. Therefore, the answer is expressed as x is equal to 9. Students, finally, the ball is in your court. At this point, I believe that you have known every skill that you need to know respecting solving ordinary algebraic equation. Please test your ability to use FDOAP in association with the fundamental rule of solving ordinary algebraic equations by solving these 70 questions. Please watch the screen and find these equations. Try your ability with each question, starting with the simplest one, and you progress to the most complex. Surely, by the end of the exercise, you will discover that you have become proficient in solving ordinary algebraic equations. Please find the questions.